Today I'm going to talk about how you can build a water sensor that you can deploy in the field, say in an ephemeral wash or in your basement if you want to know if your basement's flooded, using these cheap little water sensors that you can purchase on eBay. And essentially what I've done is encase this little water sensor in a piece of PVC tubing that has holes in it so that water can rise and trigger the sensor, and then the signal on the sensor is basically relayed to, in this case, an Adafruit Pro trinket, but you can hook up pretty much any variant of an Arduino that you're interested in. And the point behind this for me personally anyway is in southern Arizona where I live, we have a lot of ephemeral washes that we're interested in knowing when they run and how long they run. It's really hard to get out and see when these washes are running because typically they only run when we have stormwater events. And particularly in the summer here in Arizona, our stormwater events are very local, so it's really hard to capture that data or to understand what's happening during these summer monsoons. So this is one way of actually being able to record some data. You could also hook this up to a remote environmental monitor that can post data to the internet to let you know that there's flow taking place in a wash, or send a text file to your, send a text message to your phone. And the idea behind this is essentially you would take this out into the field and you would bury it to whatever stage you want to record above ground for when this thing should trigger. I deployed something very similar out on the upper San Pedro River Basin, and it held up pretty well to the elements. These little sensors by themselves are not that great. They'll corrode pretty quickly, but having this elevated over a stream bed or over whatever you want to monitor in terms of flooding, pointed vertically down like this and encased, really makes these field worthy, so that they only get wet when water rises to the occasion, and then when the water drops they dry out pretty quickly, and they're also protected from the sun and debris in your river when it's flowing. So now I'll demonstrate how this hardware works. Essentially what I've done is I've set up a little processing sketch so that you can see the analog response off that little water sensor, and right now you can see it's pretty low. So this will scale between 0 to about 400 the way it's currently set up. And I set up a threshold in the processing sketch not only to report the analog response off the sensor, but also to change the font on that response to red when there's water present. So let's go ahead and give it a shot. So my sensor's out in the field, and all of a sudden I get a flow event. The water in the ephemeral wash starts to rise, and you can see now that the analog response on the water sensor goes way up. And then when my stage drops in the ephemeral wash, the response goes back down. So again, this can be hooked up to a data logger. It can be hooked up to an auto sampler to trigger the auto sampler to tell it to pull a sample. I can hook this up to a remote environmental monitor if I want to be notified that there's flow in the wash and to go out and collect the sample. There are all kinds of interesting things you can do with this at very low cost. Okay, so next I'll go over the steps needed to build your water sensor housing. First thing you're going to want to do is get your hands on some 3/4 inch PVC, and make sure you have a length that's long enough to create the geometry for your field installation. And you'll also want 3 elbows. And finally, these PVC cutters that are shown in blue on this slide make it really easy to cut this PVC. If you don't have PVC cutters, don't worry about it. You can also use a hacksaw. Okay, next you're going to want to cut the desired lengths of your PVC and lay them out for the geometry that you want to have deployed out in the field. And remember to account for about a 1/2 inch extra on the PVC lengths so that they can seat properly in those elbows. And to truly make this field worthy, you're going to want to make sure you get your hands on some PVC primer and PVC cement to glue all this together, and also some silicone to kind of seal the electronics in the housing for the water sensor, and I'll explain how to do that in a second. And again, I just want to emphasize that with respect to the housing for the water sensor, remember that that housing has to seat into that 3/4 inch elbow, and you want to make sure that that sensor is fully protected. So the next thing you want to do is drill some holes in the housing for the water sensor. And in my case, I just used a cordless drill with a 3/8 inch paddle bit, which cuts really nicely through PVC. If we don't have these holes in this piece of the housing, what will happen is the water will come up and it will create a little air bubble in this area, and the water won't be able to rise up through the housing and trigger that sensor. Next, go ahead and feed the wire through the PVC and the elbows that make up your housing. And once the wire is threaded through the housing, you can go ahead and use your PVC primer and PVC cement to glue all those elbows and PVC pipes together. And when you get to the piece of PVC with the holes in it that's going to house the sensor, hold off on gluing that off. We're not going to do that quite yet. The first thing we're going to do is actually attach the sensor to the associated wires. Next, let's go ahead and get that water sensor ready. What I've noticed in the field with these is because those leads are located so close to one another, condensation will cause false positives. So the way to get around that is to take an X-Acto blade and just cut some of the leads, specifically the ones that are shown on this slide, to make the distance between those leads that are still working a little bit wider, and that will make it more difficult for condensation to trip this sensor. Next, we're going to get ready to attach the leads from our signal wire that's coming out of the PVC to the water sensor. And you can either solder these on directly, or you can use a cuttable proto board to make the connection. And I'll demonstrate how to use both approaches, starting with just making a direct connection. So if you're going to do the soldering, make sure to add your shrink wrap to the wire first so that you can insulate the leads and prevent shorts once everything is all linked up. Next, you're going to want to obviously apply a little bit of flux both to the wire and the leads coming off the sensor, and then just solder everything up. And finally, you're going to want to move the insulation down over the leads and apply a little bit of heat to cause it to shrink over the same, and that insulation will help prevent shorts between those contacts. I've found that using this cuttable proto board is actually a lot easier for making these connections, and I'll demonstrate how to do the same. First thing, of course, is you're going to want to cut a little bit of proto board to help you make the connection. And then you're going to want to bend the leads on the water sensor so that they can attach to that proto board. You'll simply solder those leads to the proto board. And you're going to want to make sure that you test those leads with a multimeter to ensure that there are no shorts between those solder joints. And finally, you'll want to attach the signal wires coming out of your PVC housing to this proto board to make the connection with the water sensor. Next, we're going to use that silicone to protect our electronics. So essentially what you're going to do is encase everything above the white line shown in this slide with silicone, and then everything below the white line will be exposed to the atmosphere, so that the only thing that's really exposed to the atmosphere are the leads themselves. Before you apply the silicone, go ahead and take the wire that's in the PVC housing and pull on it to pull the attached water sensor close to that elbow. So next, what you're going to want to do is apply that silicone over the front of the sensor, basically covering all those electronics that are exposed. And this will prevent those electronics from getting submerged in water during a flood event. And for good measure, we're going to apply silicone over the back of the sensor, ensuring that any circuitry or leads are completely covered. And once your silicone is dry, go ahead and apply that final piece of PVC housing around that sensor. Make sure that you glue that on with your PVC cement. And finally, make sure that you use one of the holes in that PVC housing to access the void that's currently located all around that water sensor. Because what we want to do is prevent any water from coming up through that PVC housing during a flood event. Next, go ahead and take a look up through that PVC housing and make sure that everything is nice and sealed with that additional silicone that you inserted. Before you install your sensor out in the field, you're going to want to make sure that you test it. Go ahead and open up your Arduino IDE and serial terminal and make sure that the sensor is providing a change in the analog response when it's exposed to water. Always test this stuff out before you deploy it. Okay, the wiring for this circuit is actually pretty simple. As you can see here, all we're doing is we're connecting the positive pin on the sensor to digital pin 4 on our microcontroller. And what that will do is it will allow us in our sketch to basically turn on the sensor. And then, depending on how much moisture is on the sensor itself, we'll get an analog response that's sent out by the signal pin, which is attached to pin A0 on our microcontroller. And here's the code for this circuit, and you can see that it's fairly simple. All we're really doing is setting pin 4 high, which is analogous to turning the sensor on. We're waiting 1/4 of a second, and then we're reading the sensor pin, which is pin A0, and we're storing the result in a variable called flow status. We're outputting that flow status via serial.print, and then we're basically turning the sensor off by setting pin 4 low. And then by delaying 1,000 milliseconds, everything is basically shut down for 1 second, and then it starts all over again. Next time what I'm going to do is summarize how you can integrate one of these field-worthy water sensors into one of the remote environmental monitors that was described in a prior chapter of this playlist. So if you're interested, please consider subscribing. Stay tuned for updates, and we'll keep you posted.